So today this is inverse trig. Now what's the difference in trig and inverse trig? The main thing is that like trig, we used it for finding the missing sides of a triangle. So for example, we'd have an angle in one side and then we would say, we would plug it into our formula and solve for x, right? And find the missing sides. Inverse trig is used to find missing angles, okay? So the little angle in the corner of the triangles, it's used to find that. So on these, if we have two sides of a triangle, we can use the inverse trig to discover what's the angle equal if we don't know one of the angles, right? If you look, this first one, sine of theta equals opposite over hypotenuse. Does anybody remember what that represents there? The angle? Specifically, what's that angle called? The what angle? Starts with an R. The what? The reference angle. Remember, it's the one that like we referenced when we start at. Okay. So this theta here started with the reference angle, and then on this other side of the equal sign was opposite over hypotenuse. It was the ratio of our sides, right? Now, inverse, what it does is it literally switches those around. So instead of having in the parentheses the theta or the reference angle, we have the ratio. And then on the other side of the equal sign, you now have the theta. Okay? So it literally just took them and flip-flopped them. Okay? And then we put a -1 just to say, like, hey, this is the inverse. Okay? So we switched them around. And then, so all we do is plug this into the calculator, and it'll give us what the angle is. So let's do example. So number 1. It says, find the measure of the indicated angle to the nearest degree. So we're going to do SOHCAHTOA. We're still going to use SOHCAHTOA. And this time, notice they have a question mark where the angle is. We're going to put an X there. So write an X at that question mark. Now that 29, is that opposite, adjacent, or hypotenuse from the X? Opposite, because it's across from it, right? It's opposite. And then what is the 32? Hypotenuse. How do we know it's a hypotenuse? Good, it's across from the 90. So that's my hypotenuse. Okay. So what two letters do I have that they gave me the side lengths for? O and H. So am I going to use SOHCAH or TOA? So, because it's got O and H in it as well. And what does the S stand for? So we're going to do sine. And since we're looking for an angle now instead of a side measure, I'm going to do sine inverse. What's the ratio for sine? What over what? Opposite over hypotenuse. And it's equal to our angle, or theta. All right, in the next step, we're just going to simply plug in. Sine of inverse. What's the opposite is what? 29 over the hypotenuse. 32. And the theta we don't know, so it's just x. Now this last step here is just going to plug that into your calculator. You want to make sure you're in degrees again. So the nearest degree, x, is equal to 65 degrees. And since it's an angle, I have a degree measure. If you don't put an angle symbol, I'm not going to, or the degree, I won't take it off. But it's just the right way of technically writing it. All right, number 2. Find the measure of the indicated angle to the nearest degree. So once again, I'm going to do SOHCAHTOA. This is my x. 16 is what? What side? Opposite. It's across from it, right? The 29 is what? The adjacent. It's right next to it. Okay? So we have O and A. So which one want to use, class? TOA, right? Yeah, so we can use tan inverse. TOA is, what's the ratio? What over what?
Opposite over adjacent.
Over A equals theta. Then we plug in for it. Tan inverse. We said our O was 16. Said our A was 29. Is equal to X. Now we're just going to plug that in our calculator. Tan inverse 16 divided by 29. So he said everybody says 29 degrees. Number 9 says find each angle measure to the nearest degree. Notice, does that say cosine A or cosine inverse?
Cosine A.
Just cosine A, right? There's no negative 1. So if we were to look at the original formula, this would be cosine. The original formula right after cosine, what did we always put? Nope, that's on the other side of the equal sign. Like, what do we put in the parentheses in the calculator and stuff?
I forgot the name of it.
The reference angle, right? Or theta equals, and then the other side was our ratio. And the ratio for cosine is what over what? Yeah, A over H. Okay? So whoever did this, it's like they already plugged into that original formula. Cosine theta equals A over H. And they just plugged in A for the theta, and then 0.3090 was the ratio like divided out. All right? So they said to find the angle measure. So I'm looking for A. We don't know what that is. And remember, we know that cosine inverse, we can find the angle, right? Because more or less, we just need to switch this. So what's the opposite of switching of cosine? It's going to be cosine. And what do we call that? What's the title today?
Inverse.
Inverse. So it's cosine inverse. I'm not going to put the angle there, am I? What am I going to put right after that, do y'all think? Yep, good, the number. Because that's the ratio, right? 0.3090 equals, and on the other side it's the angle, and the angle we have here is A. Okay? I really over-explained that just so you can see like why we do it. But really when you see like, oh, cosine A is 0.3090 and I need that angle, all I got to do is say cosine inverse 0.3090. So type that in your calculator and tell me what you get for the measure of angle A. 72. Can anybody second that?
72.
72. If you're going to put the proper way, it would be measure of angle A. Because if you just say A equals 72, it's not the proper way of saying it. I'm not going to take off if you don't put it, but that's just the proper way of writing it.